Okay, now that we have the rules on this page, let's try some more examples, kind of like this. So we're going to go to the back of the worksheet, and we have 3 different examples that we're going to talk about specifically. I'm not concerned at this point that you know the name of these muscles, and actually it's better if you don't, or have any knowledge of what they do, because we can figure this out based on the rules. So again, the number 1 rule for muscle contraction is that the insertion end is pulled closer to the origin end. So let's just write that little cheat up at the top. This is the end that's actually moved. This is the anchor. Okay, so let's look at this first example here, this muscle in green. Where exactly does this muscle attach? Now you have to have some bone information. So it looks like, if we get a little closer, that it's attaching up here on the rib cage and maybe this little xiphoid process here. So costal cartilage and xiphoid process. Okay, I'll make this number 1 and this number 2. So number 1, this is also a 1, and this is a number 2. What about the other side? Where does it attach on the other side? This bone in the front of the pelvis is called the pubis. So this will be 3. All right, so everybody see how it's attaching to the costal cartilage, the xiphoid process, and the pubis. Which of these bones is likely to be the movable bone? This is a little bit of a hard example to start because remember the rule, and I'm going to write this in, but don't do this, where this is the grain of the muscle. It runs in this direction, right? You can see those little like lines. So either this muscle will contract in this direction or it will contract in this direction. We're going to go with the typical, like starting from the anatomical position just to make our life a little easier. And so if we're standing, this end up here, the 1 and 2 end, is going to be the movable end. So we'll say which of these bones out of this, we'll say the rib cage, is likely to be the movable end. Technically, we can move our pelvis if the rib cage is stable, but we'll say we're in anatomical position, standing. Which direction will the moving bone be pulled? Okay, if this is the moving side and our grain goes up and down, we already said this side is the moving side, so this must be the insertion and this must be the origin. How can we pull the rib cage down towards the pelvis? Let's take a look at our atlas. I just want to remind you that there is no chance that this entire rib cage is going to move downward and squish all the stuff that's in here. So there's going to be one of the movements that we have learned about for the vertebral column. It's going to affect the whole vertebral column. So let's see. Okay, here's our muscle. There are some other muscles on here because this muscle that we're talking about, this stuff in the middle, doesn't act alone. So we'll just concentrate on this. How are we going to move our rib cage down towards the pelvis? What is the most likely action as this gets pulled to here? So let's watch it in action. That is flexion of the vertebral column. See how this part here, this is the insertion end, gets pulled down towards the origin end, and that creates flexion. Now, where the muscle's going to be that pull it back this way towards the back, they're going to be back here because they're going to pull this way. So muscles don't do flexion and extension of the same joint. That's a very, very rare, specific, weird circumstance. The muscles on the front pull the body to the front. The muscles on the back pull the body to the back. Okay, so you have to look at the direction that the muscle's crossing. All right, so which direction will the moving bone be pulled in? Downward towards the origin, which remember is the pubis here. Okay, we said that here. What is this movement called? We saw it in the animation, flexion of the vertebral column. Okay, let's take a look at muscle number 2. Muscle number 2 is here on the front of the chest. What bones does this muscle attach to? We're looking for 3 different bones. I see an attachment here, here, and here, technically even here, but let's just go with these 3 main ones. This bone here will make number 1, that's the humerus. This bone 2, the clavicle. This bone will make 3, the sternum. Which of these bones is the movable bone? Only one of these is going to be a moving bone in this circumstance. Think about this. Your sternum doesn't move. Your clavicle can move a little bit, but the most movable bone out of all 3 of these is the humerus. So that means that the humerus is the insertion end. I'm going to put a big I here. And the other 2 are origins. And if we follow our rule and draw our arrow along the green, then we get 2 distinct arrows here. So that means our humerus will be pulled towards the clavicle and also separately towards the sternum. Now we have to figure out what action word for the humerus would that be? Humerus to the clavicle, humerus to the sternum. Well, let's do the humerus to the sternum first because I feel like that's an easier answer. So move your humerus inwards towards your sternum, and it just so happens the sternum is on the midline. So we've already learned the word that means movement of the limb towards the midline, and that is adduction. So the humerus or the arm will be adducted by this muscle of the chest. What's this one here? Move the humerus towards the clavicle. If you do this motion, if you literally try to lift your humerus towards your clavicle, you end up with this motion here. Remember, in anatomical position, this arm was down, and now we've lifted it up and it's closer to the clavicle. Let's watch it in action. Ready? Lift it up towards the clavicle. Lift it up towards the clavicle. And lift it again. What action is that? That is called flexion at the shoulder or of the humerus. So this muscle right here causes adduction and also can cause flexion. And we got that based on just one simple rule of I, insertion, moves closer to the origin. Okay, we saw the flexion. Let's make sure we understand that adduction. So we're going to start with our arm out to the side. Notice that muscle stretched way out here and watch as it shortens to pull the arm in. See how the length gets smaller? Let's try again. Watch the muscle right here get shorter. See, so it's pulling the insertion closer to the anchor point, the origin. Okay, our last example is this. It's actually one muscle on the one side and one muscle on the other. I'm going to remind you that it's 2 different muscles by drawing the separation, okay, because we have a right side and a left side represented here, but you can see it's on the back of the skull and it goes to like the thoracic vertebrae here. Okay, some cervical, some thoracic. Okay, so let's do our same process. What bones does this muscle attach to? Well, we definitely see it attaching here to the skull. That's specifically the occipital bone. So we'll make that number 1. Okay, there's number 1. It attaches to, looks like the cervical vertebrae and the thoracic vertebrae. So we'll make this 2 and this 3. Okay, and then same on this side for the left muscle. I'm putting in double numbers because we have a right side muscle and a left side muscle. Okay, just like we do with everything else. Which of these bones is the movable bone? Okay, is your skull more movable or is your cervical and thoracic vertebrae more movable? The skull is more movable. Okay, we can do neck flexion, neck extension, we can do lateral flexion, we can even do rotation to the left or right. Okay, based on this, in what two directions will the moving bone be pulled? How will these muscles, if you use them like one at a time or both at a time, how will it move the head? Well, let's write down our options and then I'll give you some choices. Flexion, that's tipping your head to the front. Extension, tipping your head to the back. Lateral flexion, that's tipping your head to the left or to the right, like ear to shoulder on either side. And rotation is turning to look to the left or the right. Okay, so based on what we see here, we know this is the insertion end and this is the origin. If our rule is I to O, our arrow should go this direction down the muscle according to like those little lines that are in it, the grain. So what would this motion be? If I moved this side, I to O, it would tip my head to the side. Say it, move I to O. It's not going to squish your neck and crush all these vertebrae and make your whole entire head move straight down onto your rib cage. Okay, we have to be reasonable. This is a flexible cervical vertebrae here. So it's going to pull this right to the side. What else? What if we used both at the same time and we pulled equally on the left and the right? We're going to pull the entire back of the head backwards towards the vertebrae. That would tip the head to the back. So this is if we used one muscle, tip the head to the side, like the left side or the right side. This is if we use both. And now we just have to say, what are these motions called? Well, if we tip the head to the side, that motion is called lateral flexion. If we tip the head to the back, that motion is called extension at the neck. So this muscle can do lateral flexion and, if you use both sides at the same time, extension. As it pulls the insertion closer to the origin, watch what happens. So this side is getting longer. That's a stretch for this side. This side is getting shorter and it's pulling. Watch again. See how that side's pulling it down? Pull it down. Okay, let's look at extension. Okay, I've had to hide some other muscles so we could see the one that we're working with here and here. So watch, we're going to use both sides at the same time, pulling equally on both the insertion points down towards the origin point for both muscles. See that? Pulls the head to the back, and we've actually decreased the distance. So we've made this section shorter as we pulled the I closer to the O. Okay, you have a couple of these to try on your own. Use the rules. The insertion end is the moving side, and it gets pulled closer to the origin end, which is the anchor, along the grain of the muscle.